Okay guys, let's have a look at question 4a then. Here it is here from the paper. An AP arithmetic series has a first term A, common difference D. Prove that the sum of the first n terms of a series is given by this. Standard formula for the sum of the first n terms of an arithmetic progression, yeah? First term with first term A, common difference D. So let's have a go at that then. It's a standard bit of bookwork, so I'll just run you through it. Question 4a, right? And then the sum of the first n terms. So Sn is equal to, the first term is A. The next term you add a D, don't you, common difference. Then you add, for the third term, you add another D, so you're going to get A plus 2D. So when you add that up, there's your first three terms. Now your last term, if your first term is no D's, and then your second term is 1D, your third term is 2D, your nth term, so this is the third term, remember? The second term is here, and the first term is here. Basically, the first term is no D's, 1D for the second, the third term. So the nth term, which I want to write here, will be 1 less D. Do you see the pattern? So without further ado, I'll just put it down. A plus n minus 1D. That's the nth term. Yeah? So that's plus. And then I want to write the preceding term before that. So it's A plus n minus 2D, isn't it? And this would be the n minus 1th term. Okay? So it's plus dot 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 plus, and then plus these two. So there's the first three terms, the last two, written that way around. Let's reverse the order then. Reversing gives. So I'm going to write the last term first and the first term last. So that goes first. A plus n minus 1D. Then the second term, second from last term, I'm going to write second. N minus 2D plus dot dot dot. And then I'm going to write these terms again. So we go down to A plus 2D plus A plus D plus A. Yeah? Okay, that's reversing. Adding. So label this as number 1. Label this as 2. Adding these two together then. What do we get? 1 plus 2 gives. Well, on the left you add the two things here. 2Sn. And on the right you're going to add this first term to the last term. First and the last. A plus n minus 1D is just simply 2A plus n minus 1D. See that? Then we add the second term to the second plus last. The A plus A gives 2A. And then the D plus n minus 2Ds, add another D is n minus 1D. Agreed? And then you can add all the others you can see. And if we go right to the end now, we've added the first and the second to those, that one and that one. If I go back to the other end, it'll be A plus n minus 1D plus A, which is 2A. Again, it's the same. So I think we've illustrated that sufficiently to demonstrate that to the reader. So there we are. So how many of these terms have we got, basically? Well, however many terms we needed to combine together. N of them. So there's n of these, aren't there? They're all identical. So there's n lots of them. So 2Sn is equal to n lots of 2A plus n minus 1Ds. Fine. Now divide both sides by 2. N over 2. Put a nice bigger bracket, I think. A brace then. 2A plus n minus 1D. There we are. There's the formula we were asked to derive. Okay, so the trick is just remembering you have to write the series down fully, one way round, write it in reverse, demonstrate to the reader by adding a first representative terms, this one and this one, that one and that one, and however many you think sufficient, and the last two together, which I did here. And the Sn and the Sn, of course, make two lots of Sn. So you end up with two lots of that. And these terms are all identical. How many of them are there? Well, there's this many, which is n. So there's n lots of this term. Divide by 2, you get the answer. Okay then, so that's 4A. Start a bit of bookwork. You should better go into an exam and rattle off something like that. in double quick time. Good. Let's go on to the next one.